Why has Python kept growing? Actually, it's things like pandas. So pandas, and there's some pandas used in the audience for sure, right? Wes McKinney, good friend, and several people now maintain pandas. Very popular library for dealing with tables of data. It depends on NumPy, but it adds some features for loading data and doing group bys and joins. It's been the foundation of machine learning frameworks. Chainer, TensorFlow, PyTorch, TVM, MXNet. Lots of these. In fact, so many of these, they're now on top of this stack that we're kind of in this exploding world of machine learning libraries and frameworks that we're in this array objects everywhere situation. There's not just a NumPy array now. There are all kinds of arrays. When you go to Python and say, hey, I want to do some data processing, now you have to ask the question, what do I do? So the answer isn't always just use pandas and NumPy. It's, oh, well, maybe I should use PyTorch, maybe I should use MXNet, maybe I should use TensorFlow. And all of those will ultimately need to interact with NumPy or pandas at some point, but we're in this world where it's really hard. The big problem is that people are building stacks on top of them. It's not that there exist other array objects, it's that people are now building things like Torch diffie-q and TensorFlow diffie-q. Like the whole SciPy stack could be rebuilt on another array object, instead of just saying, hey, I have this functionality, and I have objects I want to write on top of. So we have this divided worlds again, and it's something, it's definitely a problem on my mind. How do we fix this? How do we improve it? How do we help it? Deep learning framework, what's needed? There's a few things needed, and a lot of these libraries just implemented their own stack, except Chainer. Chainer built on the NumPy SciPy stack. TensorFlow is the most popular, but PyTorch is the most popular with researchers. So the people I talk to, developers I talk to, PyTorch is much favored over TensorFlow. TensorFlow is more popular. Google puts a lot of effort into they were the first to market as well. But PyTorch is growing. Chainer's got a really lot of people who love it in Japan, particularly if you're in robotics. Very popular. And then TVM is a framework for building deep learning libraries that's very, very powerful. And something I would look into. It's still, I would say, a research project, but it's very popular and very useful for building tools. So a few slides on Chainer I'm not going to go into just because most people haven't heard of it. But there are unification efforts that are happening right now. And this is the most important thing in my mind over the next 5 years, is how are we going to use the power of Python to bring people together as we have this Cambrian explosion of capabilities in the market. Onyx is a great thing. It's about formats. You build models. And a deep learning model at its core is arrays with functions. So you have functions on arrays with more functions on arrays. It's not that complicated. It's not like it's some magic thing that happens. Now, the functions get kind of complicated. And then you do things like automatic differentiation, and those functions you want to run on GPUs, or you want to run on multiple cores. Like, there's actually some complication in the runtime, but in terms of specifying what you want to actually accomplish, it's not that. It's basically a sequence of Python functions on top of tensors or ND arrays. I mentioned TVM AI, something useful. So this is what's on my mind right now. Where do we go from here? We've got this wonderful world of capabilities now. You can do really anything you want as a scientist with a stack that's there. But how do we go from here? How do we get support? In fact, if NumPy had already supported GPUs and automatic differentiation, if that had already existed in NumPy when the TensorFlow and the PyTorch showed up, I don't think we'd have those libraries. I think it'd be much easier to support deep learning on just the raw stack. Chainer adding it, they didn't get enough marketing power to overcome the push that Google and the mindshare Google wanted to support their efforts. So we're not going to write a new array object. The plan is not to say, here, we're going to write one more NumPy to rule everything. But there are other additional things we did when we wrote NumPy. One was create a buffer protocol. Memory view objects, which are currently in Python. That was why I became a Python core developer for a few years. Why I got to know people pretty well is actually adding, we didn't get NumPy in the language, but we got the structure of NumPy in the language, in what's called the memory view object. And people actually vastly underuse it. And when you find out about it, the memory view and the buffer protocol, you actually become like a superpower. You become this person that can do amazing things, like fast database to array computation. And so I'm starting to see people do things with memory views. I saw the Python group, for example, use memory views really effectively. So we did that, and then we also did something called array interface, Dunder array interface, use the protocol methods to come up with our notion of what an array is. So what if we revisit these earlier efforts and kind of amplify them? And if you look at what XND is basically the buffer protocol extended to cross languages. So it's the memory view with an enhanced type system, now available for C, in C, so you can cross between Ruby and Python and Java and JavaScript and Node. You can basically have this cross-language buffer protocol. And then array interface, XND is fairly maturing. It's basically usable today. UArray, NumPy, these other efforts are just ongoing, just started. So I have some slides here, but for short of time, I'm going to jump ahead. XND is not a NumPy replacement, but if you're somebody looking to build tools, you can definitely use XND. XND's got it's got a type system, it's got mathematical computation, and it's got an array container. It can do things like arrays of strings, whereas NumPy can do arrays, it can do variable length strings. NumPy's arrays are all fixed strings. It can do arrays of pointers, it can do arrays of category types, it can do arrays of missing value data types. A lot of the data types that are missing, variable length arrays. So you want a ragged array. You want a two-dimensional array where the first dimension has length 3 and the second dimension is variable lengths. You can't do that with NumPy. XND allows you to do that. You can have category types. You can have very deeply nested JSON types. and then have an XMD or a container around it, and then write fast code against that. Makes it very straightforward to do high-level bulk computing on data as opposed with high-level operations. It's a generalization of NumPy, as I've said. Arrow is another project that's a generalization of pandas. So a lot of people have heard of Arrow. Wes has been working on Arrow for a while. XMD could be thought of as a generalization of NumPy in the same way. Okay, so my time is just about up. Unfortunately, I'm coming to the end. URA is this goal, basically, to bring together all these high-level packages. They're all currently relying on NumPy and now PyTorch and TensorFlow. What if we actually we had a way for all these high-level libraries like SciPy, scikit-learn, to rely on an interface that then had mobile backends? The current NumPy backend, could be a PyTorch backend, could be a DAS backend. So that's that idea. Our NumPy, our pandas, is a new project just started a couple of weeks ago. We're trying to take the core of NumPy, the core of pandas, and get its most basic element. NumPy is huge, API, pandas is a huge API. If we shrink them, find their core element, we have more of a hope of implementing the universal array interface. So what's the future? Well, as I mentioned before, I'll restate it. There was a Cambrian explosion of array computing over the past 5 years. It's glorious. It's wonderful. It's allowed us to do amazing things. And you, as a Python user, are now, you can do data science, you can do deep learning, you can do machine learning, you can do more than just, you can go everywhere from cooking toast to making breakfast. It's amazing what you can do with Python today because of this, but it's also confusing. And so over the next 5 years, I hope we see more standardization and more unification of some of the APIs so that the next platform that our future 5-year friends come into will be stronger and a better foundation for the future.